This is Chris from systemsarchitect.io. We're detailing 15 AWS DynamoDB strategies, a table that scales to millions of requests per second without anyone paging an on-call engineer sounds like magic. It's really the product of deliberate configuration choices. DynamoDB rewards teams that design for its model instead of forcing a relational mindset onto it. The gap between a table that just works and one that quietly wastes money or throttles under load usually comes down to a short list of well-known techniques. This video walks through 15 strategies for getting real value out of DynamoDB. That's everything from choosing the right capacity mode to locking down access with fine-grained IAM policies. 15 AWS DynamoDB strategies. 1. Choose on-demand or provisioned capacity mode. 2. Enable auto-scaling for provisioned tables. 3. Model tables around actual access patterns. 4. Use global and local secondary indexes for query flexibility. 5. Stream real-time changes with DynamoDB streams. 6. Set time to live to expire stale data. 7. Query with particle for SQL-like flexibility. 8. Enable point-in-time recovery. 9. Choose query over scan for efficient reads. 10. Use transactions for atomic multi-item operations. 11. Monitor performance with CloudWatch alarms. 12. Rely on adaptive capacity to prevent hot partitions. 13. Enforce fine-grained access control with IAM. 14. Schedule backups with AWS Backup. 15. Reserve capacity for predictable workloads. 1. Choose on-demand or provisioned capacity mode. Why choose provisioned over on-demand? On-demand mode charges per request and scales instantly, which suits new or unpredictable traffic. Provisioned mode costs less per unit for steady, well-understood workloads. Many teams start on demand, then switch once real usage patterns emerge. The mode can be changed later without downtime. 2. Enable autoscaling for provisioned tables. Autoscaling watches consumed capacity and adjusts provision throughput automatically. It should cover both the base table and any attached GSIs, since an unscaled index becomes its own bottleneck. A lower target utilization leaves more headroom but costs more. Pairing autoscaling with scheduled changes helps for known traffic events. This video is a condensed version of what we have on systemsarchitect.io. See the full section there. Also make sure to like the video and subscribe to the channel for more and check the video notes for links. 3. Model tables around actual access patterns. Effective modeling starts by listing every access pattern before designing keys. Single table design keeps related data retrievable in one request instead of requiring joins. Denormalizing data trades some duplication for fewer lookups when reads dominate. Getting key schema right up front avoids costly redesigns later. 4. Use global and local secondary indexes for query flexibility. GSIs use their own partition and sort key suited to a different access pattern altogether. LSIs share the base table's partition key but sort differently within it. LSIs must be created with the table, while GSIs can be added later and scale independently. DynamoDB global tables now also offer a multi-region strong consistency option in preview. It's worth auditing indexes periodically and retiring ones no longer driving real queries. 5. Stream real-time changes with DynamoDB streams. Streams capture a time-ordered log of item-level changes for up to 24 hours. Pairing a stream with a Lambda function turns the table into an event source. Streams are also how global tables replicate changes across regions under the hood. Treat them as a reliable trigger, not a long-term audit log, since the retention window is short. 6. Set time to live to expire stale data. What does TTL actually do? What does a time? TTL automatically deletes items past an expiration timestamp at no write cost. It suits data with a limited useful life, like session tokens or cache entries. Deletions typically complete within 48 hours, so it isn't meant for time-critical removal. Combining TTL with streams is a common way to archive expiring data to S3 first. 7. Query with Particle for SQL-like flexibility. Particle gives DynamoDB a SQL-compatible syntax alongside its native API. It still respects DynamoDB's underlying key structure and throughput model. This makes it especially useful for ad hoc fixes, debugging, and cross-database tooling. Treat it as a convenience layer, not a substitute for understanding access patterns. 8. Enable point-in-time recovery. PITR continuously backs up a table and can restore it to any second within 35 days. Because it runs in the background, there's no backup window and minimal performance impact. A restore always creates a new table rather than overwriting the original. It's worth pairing PITR with a documented, practiced restore runbook. 9. Choose query over scan for efficient reads. Query and scan look similar at a glance, but they behave very differently under load. Why prefer query over scan? Query reads only items matching a partition key, so it touches just what's needed. Scan reads the entire table and filters afterward, so you pay for every item scanned. Any regular production access pattern should be served by query, reserving scan for rare, low-priority jobs. 10. Use transactions for atomic multi-item operations. Transactions group up to 100 actions across tables into one all-or-nothing operation. Transact write items handles atomic writes, and transact get items reads a consistent snapshot. They cost roughly double the equivalent non-transactional operations. Conditional expressions can be layered in to enforce business rules as part of the same operation. 11. Monitor performance with CloudWatch alarms. CloudWatch tracks consumed capacity, throttling, and errors for every table. A sustained rise in throttled requests usually means capacity is too low or a partition is hot. Alarms on these metrics catch problems in minutes instead of at the next review. Watching how often auto-scaling actually fires helps tune the target utilization. 12. Rely on adaptive capacity to prevent hot partitions. Adaptive capacity automatically shifts throughput toward partitions seeing heavier demand. It's enabled by default and needs no configuration at all. It complements good key design rather than replacing it. A partition that stays hot despite adaptive capacity usually signals a key design worth revisiting. 13. Enforce fine-grained access control with IAM. IAM policy conditions can restrict access down to the item level, tied to the leading key. That makes it possible to isolate one tenant's data within a shared multi-tenant table. Conditions can even limit access to specific attributes within an item. AWS Private Link keeps DynamoDB traffic off the public internet entirely. Reviewing these policies regularly keeps access aligned with what the application actually needs. 14. Schedule backups with AWS Backup. AWS Backup adds scheduled, policy-driven backups retained for months or years, beyond PITR's rolling 35-day window. One backup plan can apply consistently across many tables at once. Because these backups are stored independently, they survive even a deleted table. Running periodic restore tests is what separates a real backup strategy from one that only exists on paper. 15. Reserve capacity for predictable workloads. Reserve capacity trades a 1 or 3-year commitment for a meaningfully lower hourly rate. It only pays off for genuinely steady, predictable traffic. The right size comes from months of actual usage data, not a guess. It's worth revisiting the commitment periodically. Reserved capacity is often the single largest lever for cutting cost on an already well-optimized table. To sum up, getting the most out of DynamoDB comes down to matching capacity mode and data modeling to real access patterns. Layer in monitoring, backups, transactions, and access control on top of that, and the table stays reliable as it scales. None of these 15 strategies require exotic tooling. They use capabilities DynamoDB already provides. Start with whichever gap feels most immediate and build outward from there. Thanks for checking out this video. Hope you liked it and subscribe to the channel. Find a lot more articles and guides both on systemsarchitect.io and codeguides.io. Again, that's systemsarchitect.io and codeguides.io.